So in this little video clip I'm going to demonstrate what we'll call the spurious regression example. As you know from the lecture notes, we need two series x and y, and we generate them as random walks. Let me just briefly illustrate what that means. So we say yt equals yt minus 1, so the previous value plus an error term ut, where we have to say how that ut is distributed, and we'll say that this comes from say standard normal distribution. Then we're also looking at xt, and we'll simulate that in exactly the same fashion. It's a function of its previous value plus an error term, different error term, so vt, and that vt as well is, let's say, comes from a standard normal distribution. So two things. One important thing you need to recognize, that nothing in xt is related to what we do in yt, so they will be totally unrelated. So the first thing we need to do is we need to simulate the u and the v, and the way we do that here in Excel is that we use the data analysis function, because that has a nice random number generator. If you don't have the data analysis function yet, so if you click on your data and you can't see it here, you will have to go to add-ins and add it there. You go to options and then go to add-ins, and it's the analysis tool pack. It's called analysis tool pack. If that doesn't appear in the active application add-ins, it will appear in the inactive ones, and you have to click on it and then click OK here, and that will install it. Don't ask me why in their wisdom Microsoft hasn't done that from the outset, but here we go. So let's go to the data analysis. We want random numbers. Let's say we want 2, because we want u and v. Okay, let's say we'll get ourselves 1,000 observations. Here you can choose the type of distribution. We'll say normal distribution, random seed. Forget about that. If you put a certain value in here, you will always get exactly the same numbers. And output range, I want to put it here, so let's say okay. So here are our random numbers. Now okay, so these are all random numbers. If you were to, and you can see, if you look at the values here, they're all between, mainly between -2 and 2, as you know, most of the observations in the normal distribution will be. So then why? We need a starting value, so let me just use 0 as starting values, but you can choose anything. And y is going to be its previous value plus the random term u at period 2, that's the second observation. So y2 equals y1 plus u2. And if we copy this down, so here for instance, let's make sure our formula is still the right thing. Yeah. So this observation for y is its previous observation plus the random term u at that period. So for x we want the same, so we'll just copy that across. So let's check we do the right thing. Yeah, previous value plus error term v at that period. And if we copy this down, I'll just check this one, previous value of x plus the error term. So that's all good. We copy this down. Now let's look at a time series plot of these two guys. Here we go. Okay, so you can see what we see here. These are two series. They're both very persistent. One seems to be, at least for 2/3 of its life, seems to be trending down, and the other one is sort of hovering around more or less the same value. Now, of course, we know they are not related to each other. That's very, very important here to recognize. They are not related to each other. Just copy it to the top. unrelated series. That means if we can trust our regression analysis tool, which we talked about so far, if we run a regression of y against x, we should find that we shouldn't be able to reject the null hypothesis that the coefficient to x should be 0. So let me write this down. Regression model yt equals, let's call the coefficient a0 plus a1 times xt plus an error term epsilon t. So if you run this regression, the null hypothesis that a1 is equal to 0 we should not be able to reject. Well, at least if we do this at an alpha of 5%, we should not reject it in 95 out of 100 cases. So the alternative is going to be not equal to 0. So this is what we're going to do, and we're going to quickly use the regression tool in Excel. Could of course use EViews, wouldn't be a problem. It's just as we have it open here, X range. So X range, Y range, we want a constant, that's fine. Where do we want the output? We'll have the output somewhere here. And we click OK. So, what do we get? We get an R squared of 20%. Okay, quite something. Okay, not close to 0. Let's look at our coefficients. Our constant is 16 and clearly significant, but you know, well, we can't interpret it. What about the coefficient A1? 0.169, that by itself doesn't say anything. Look at the standard error, 0.01. The t-stat is 16. So if we were to do any normal hypothesis test, we would clearly reject the null hypothesis. That means this null hypothesis here, A1 equals to 0, would be clearly rejected. Now what has gone wrong here? Because we know these two guys are not related, y and x are not related. Well, what has gone wrong is that if a process follows this type of process, okay, we call this a random walk. These guys are not stationary processes, or they are not weakly dependent, okay, and for that reason time series assumption 1 is breached. That means this entire lot we can't trust, okay, or in particular these test statistics here we can't trust. Now, how should you know? Does Excel know? Nothing. This is what you need to study my course for, so you know. So well done, and that video finishes here.